What we have here is proof by induction that the sum of the first n natural numbers 1 plus 2 plus 3 plus dot dot n is n over n plus 1 over 2. So what we can do first is we have to prove for p of 1. So prove for p of 1. What that means is that the left hand side is equal to 1 and the right hand side is going to be equal to replace n equals 1 in, and you get 1 into 1 plus 1 all over 2, which is going to be equal 1. LHS equals RHS. It's going to be true for P1. Okay, once you've done that step, okay, extremely easy, you're going to next assume true for P of K. Assume true for P of K. Now when you do that, we're going to get 1 plus 2 plus 3 plus dot 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 plus K equals K into K plus 1 all over 2. Now, once you've done that, what you're going to do next is we're going to prove for P of K plus 1. Now, prove for P of K plus 1, okay, means that we're going to have the same sequence here. So we're still going to have 1 plus 2 plus dot 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 K. However, we're going to have the additional term K plus 1 at the end. And this is going to equal, when we replace K with K plus 1, we're going to get K plus 1 bracket K plus 2 all over 2. What I'm going to do next is, and I'll save some space by doing this, I'm going to replace this part here with this part in here. And what I'm going to get is K bracket K plus 1 all over 2 plus this. Now, we could do it two ways, okay? Probably the best way to do it for you guys is probably, what we're going to do is they have a different denominator. So I'm going to multiply the top and bottom by 2. I'm going to multiply it out. I'm going to get K squared plus K plus 2K plus 2 all over 2. And that has to equal K plus 1, K plus 2, all over 2. Now, if I add this together, which I'll do now, I'm going to get 3K. And then, if I factorize the top, I'm going to get K plus 1, K plus 2, all over 2. Equals K plus 1, K plus 2, all over 2. So you can see that you write down the usual spiel, hence P of K plus 1 is true if P of K is true, hence by the principle of mathematical induction, P of N is true. Did everybody get that one out? The induction? Yeah? It's alright? Now, that's done. All I'm doing is looking at this one here. Now, this one here, guys, is basically what we're going to be doing with this one. Is it says hence or otherwise prove the sum of n even natural numbers. Okay, n even natural numbers. So, what I did, what page is this on again? 277, okay. So, oh yeah, different one to use. Okay, so what I would have done with this one was I had two choices, okay. The two choices were I could double the first one. So we've already proven 1 plus 2 plus 3 plus dot 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 n And we proved that that equals n over 2 into m plus 1. If you look at this and look and compare, n, 2n, 1, 2. You've basically doubled the value of everything and added it together. Okay? So it's going to be double the sum. So what I'm going to get instead is, it's going to be, if you multiply everything here by 2, what you'll get is 2 plus 4 plus 6 plus plus 2n, and then multiply that by 2, and you're just going to get n bracket m plus 1. Okay? And when you do that, what you're going to get is n squared plus n. I had an alternate to that as well. My alternate to that was to use an arithmetic sequence. I could use a equals 2, the d value, anybody? 2 for this part here, 2, 4, 6, 8, yeah? It's an arithmetic series. So then I'll just say Sn equals n over 2 into 2a plus n minus 1 times d. And then once I look at that, I say, okay, that's going to be n over 2 into 4. That's going to be 2n minus 2, isn't it? When I multiply d is 2 by n minus 1. And then 4 minus 2 is going to result in 2n plus 2 on the inside bracket. Because that there is 4, and that's 2n minus 2. And that's going to give us 2n plus 2. Divide by 2 and multiply n by n, and we'll get n squared plus 1. Or n squared plus n. So you can see two different ways of doing the same question. Either double your first answer, or start from scratch and do a new arithmetic series. Now, using the results from A and B above, find the expression for the sum of the first n odd natural numbers in its simplest form. Now n odd is different, okay? So if I went from 1 plus 2 plus 3 2n minus 1 plus 2n. Do you understand what I did there? I got the sum of the first 2n. Would you agree with that?
Yeah.
All the way to 2n. It is double. Would you agree it's double the blue one? It's double the size. It's like the first one's gone up to 10, but the second one's gone up to 20. Including everything, 18, 19, 20. Well, the first one goes 8, 9, 10. So we know that this one here is, what was it at the very top again? N squared plus, is n over n plus 1 all over 2. Now, a common mistake would be, if I said 1 plus 2, just took 2 of them, right? And on the next sequence I took 4 of them. Do you notice that it's not doubled? The sum of the first 2 terms is 3. However, the sum of the first 4 terms is 10. So it doesn't go up in proportion, does it? So I am doubling the size by doubling the length of the series. It's not doubling the size. Is everybody happy with that? It's not doubling the size. So therefore, what I need to do is, this formula is based on the ending n. It's based on ending at n. But this time I'm not ending at n, I'm ending at 2n. Therefore, the sequence in question should go all the way up to 2n. So therefore, what we have here is going to be 2n bracket 2n plus 1 all over 2. And that therefore is going to be 2, what's it going to be, divided by 2, cancel, yes, you can just work away, n times n. So, what we had here, guys, was we realised that it's going to be n into this, so it's going to be 2n squared plus n. Is everybody happy with that? Yeah. 2n squared plus n. So, I'm now at the stage where the first n terms, the first two n terms are going to be, sorry, 1 second. This equals, what's it, 2n squared plus n, wasn't it? Okay. Now that's what we got there, okay? Now, what we have to do is we have to take away an expression for the, we've already gotten the first n even numbers. Do you understand by the first n even numbers? What we're going to end up doing is we're going to take away from this, we're going to take away 2, we're going to take away 4, we're going to take away 2n, and before that we had 2n minus 2. So if I take away this answer here, I'm taking away all the even numbers out of the first 2n terms. So what I'm going to do next is I'm going to get this 2n squared plus n. Now it does say use the results above. You have to use the results above, a and b. Okay, so you're going to do 2n squared plus n, take away n squared plus n, and the answer is n squared. Okay, basically I'm taking away all the even numbers out of the full sequence, and that leaves the odd numbers left over. Okay, and that's how we get the odd numbers on their own. Any questions on that?
Yeah.
Okay, go.